Good afternoon. Myself Rahul Asmat. I am currently pursuing computer science and engineering, which is specialized in artificial intelligence and machine learning. So this project is my internship final project, and uh, the project is LLM evaluation and prompt optimization system. The objective of this project is to evaluate the performance of large language models using different prompt strategies such as few short, concise prompts, structured prompts, role prompts, and improve their outputs through systematic prompt optimization. So for this, we are using the models that is Llama 3.2 of 3 billion parameters and Gemma 2 of 270 million parameters. These both models are used to compare, and Llama 3 is used for prompt optimization. So in our system, first we in the first iteration, we are using the original prompts from the dataset, where the raw prompts from the dataset are passed through both the models, and then the responses are generated, and these responses are evaluated. Then in iteration 2, we are optimizing these raw prompts using the LLM, that is Llama 3, and which focuses on clarity and structure of the prompts. And here the prompts are optimized based on their prompt type. For example, if there is the prompt type is few short, then it is optimized according to the few short prompt type. And in the iteration 3, it is the score optimized prompts. Here the prompts are aligned with the evaluation matrices, which enforces here we are which focuses on concise and precise responses according to our ground truth or the reference we are giving. So here we are using the evaluation matrices that has BERT score, ROGEL, and embedding similarity. So as of now, we are using the BERT score because it compares the meaning between the response and the reference using the transformer embeddings, which works even if working is different. For example, if we are using, for example, there are two words car and vehicle, then it is still similar. Next, we are using a ROGL, that is which measures the common sequences of the words, and it ensures that there are important keywords in the generated response. And then we are using the embedding similarity, which converts the sentences to the vectors, and then these vectors are uh, and then we are performing the cosine similarity on these vectors. So, and then the final score is calculated using the BERT score embedding and the ROG. And here we are providing the BERT score the high value because the BERT score uh, compares the models. It compares the responses, and it evaluates based on the meaning of the responses. So if the meaning is uh, accurate or somewhat similar to the reference, then it provides higher scores. So here we are using the data set in the format that is the prompt. Here it is the input prompt. It is of a raw prompt, and here the prompt type. Here the raw prompt is of which type, and then reference, which is the expected answers. So as of now, here are the installation steps and how we have to perform. And we are using visualizations using the Matplotlib library for model performance comparison and other things. So let's move to these are the other things after the I will explain after the code. So this is our code book, and in the first step, we are installing the required libraries for our project, that is Pandas, TQDM, Request, Evaluate, Sentence Transformer, Scikit-learn, RogScore, and ScareBlue. Sorry, we are not using ScareBlue because Blue was uh, based on n-gram matching, and it does not capture the semantic similarity, as the LLM outputs are often meaningful, but they use the different words than the references. So the ScareBlue was uh, not performing good, so I have removed it. And next, we are importing all the required libraries or the required libraries, as here we are using the Pandas, Request, Time, and TQDM, Evaluate, Sentence Transformers, and Scikit-learn. And here from the Sentence Transformer, we are importing Sentence Transformer, and from sklearn, we are importing the cosine similarity, which is used in embeddings. And next, here we are using the here we are giving the Olama URL, and we are using the models that is Llama 3.2 and Gemma 3. We are using these models for testing, and optimizer model we are using Llama 3 latest. So here are two functions, that is Olama generate and save generate. In the Olama generate, here it sends the post request to the Olama server with the model name and the prompt, and it returns the generated response. And in the save generate, this ensures that there is the stable execution between the pipeline by handling the temporary API failures and avoid the crashes. Here we are reading our dataset using the pandas library. I have forgot to install the bird score. Then I have installed in the sixth step, that is the bird score, and we are using the evaluate to load the bird score rows, and here we are using the embedded model and here we are using the embedded model, that is all mini, which converts the text into the vectors. And this is our evaluate function. This code sets up the evaluation system by loading the bird score ROG matrix and embedding similarity. Here we are calculating all the here the here all the evaluation part is done. Our first iteration, here the original prompts are passed through the both the models and the responses are generated. Here the responses stored are in the form of list, so they are converted into the data frame, and these results data frame is then processed through evaluate data frame to produce the results. So in the next step, here we are performing the prompt optimization using the another LLM, and here we are giving a metadata to the optimizer model, that is you are an expert prompt engineer, rewrite the prompt. The main thing is that it had to generate the prompt based on the prompt type which is provided in the dataset. For example, if there is a role based prompt type, then it will generate the prompt which is based which it is on the role based. And next, with this metadata and the original prompt, these both are passed through this optimized DF, optimized results, that is the metadata and the original prompt are combined, and then it is passed through the optimizer model, that is Llama 3, and it generates the optimized prompts. And these optimized prompts are again passed through each models one by one, and it generates the responses. These responses are again generated in the list format, which are converted into the optimized data frame, and this optimized data frame is evaluated. This step, the both the results before score and after score, that is the both the data frame results DF and optimized DF. Here both the final scores are combined into a comparison table and improvement, and this has helped to analyze whether the prompt optimization improved or reduced performance. As you can see, it has reduced the performance. This is because the improved prompt generated the results which are more structured and well versed, which than the earlier original prompts. That's why the score has reduced, because as our reference answer is smaller. As you can see in the visualization also, the score has reduced, but we can optimize the prompt for our evaluation matrices. Then we can rewrite the then we are creating a function that is which we are providing another meta prompt, that you are expert in prompt optimization. Here it avoids the unnecessary details, and it provides the required details which are uh, matching to our reference. And here also here it is using the prompt type to generate the prompts. And in this step, we are generating the score optimized prompts, that is uh, the metadata and the original prompt are passed through the Llama 3.2, Llama 3, and it generates the optimized prompts. And next, here the optimized prompts are passed through both the models, and here it generates the responses, and it is the third iteration. And here uh, after the both the models generates the responses, these responses are in the format of list, which is converted into the data frame, that is score DF, and then they are evaluated. After evaluation, you can see the scores has score optimized score has increased, it has increased more. And here is a visual representation of how the score has increased and how much has increased. And here the model comparison, you can see Llama 3.2 is performing very well across all the prompt strategies, not only single prompts, but it is performing very well across all the prompt strategies. And here we are uh, uh, seeing the leaderboard. It is the final leaderboard. You can see here the model Gemma 3 with the prompt type basic has generated the highest final score, which is score optimized. So if we are looking for a optimized scenario, then the best model is Gemma 3, and if uh, optimized scenario, then the best model is Gemma 3 prompt type basic, and we are using the strategy score optimized, that is score. But if we are looking for a model which is um, performing uh, best across all the three phases, that is original prompts, optimized prompts, and score based optimized prompts, then then llama 3.2 is scoring very well, that is 0.601, which is better than the Gemma 3. So overall conclusion is that if we are using for best optimized scenarios, we can use the Gemma 3, or which we are if we are looking for general robustness and consistency, uh, we can use llama 3.2. So these are our the key insights is that prompt optimization must align with evaluation matrices. As the answers or the responses increase, this reduces the similarity based scores, and the concise prompts improves the evaluations. Different models respond different to the prompt changes. Robustness and peak performance are distinct evaluation criteria. Here there are some future improvements that we can use another LLM which is a stronger model than these, uh, can be used as and judge for evaluation. We can build the Streamlit dashboard, multi-round prompt optimization, support additional models. This is my project, and this project demonstrates how the prompt optimization and prompt evaluation can significantly improve the LLM performance. Thank you so much.